All right. So we have our uncertainty, we have our sphere in meters. Now we need the prediction. Accepted, not the prediction. We need the charge. So this is going to be our charge calculation. If you guys remember, the charge calculation is voltage times the radius, okay, times, and I'm not showing you guys. Yeah, I'm not going to show you guys how to stop the video and then just look at those. But the charge on the spheres going to be in coulombs. Oh, it keeps putting that doggone thing. Oh, I like it. See, put a space in there so that copyright symbol doesn't come up. So this is going to be equal to our voltage, all right, times the radius of the sphere divided by Coulomb's constant, which we already have down here. All right, so that's the charge on the sphere at 6,000 volts. Let's go ahead and just drag. So one of the things that I did not do, the radius of the sphere, which is in M2, I didn't make it static. So if I pull this down, you're going to see something. So you have division by 0. So I'm just going to undo that. What I want to do is I want to make these static, everything except H. So this one is static. You do that by hitting your function key 4. If you're on a Macintosh, find the FN key, hold that down, and then hit the function key 4. And it's going to make this static. All right. E needs to be static as well because that's Coulomb's constant. So I'm going to hit my function key again. And then when I bring this down, okay, we have the charges that are on the spheres. All right. So this is large. It's getting smaller. It's smaller, 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 smaller. Makes sense because the voltage is decreasing. So now we need to square charge on these spheres. Now, how does that look? We got to put that C in there. I'm definitely going to square it or put my superscript to take that superscript away, say okay, and then enter. All right, so this is the charge on the spheres. And we're just going to use our function power. And I'm going to select this value and then say squared. All right. So let me go ahead and just double click on my fill handle. Oh my gosh, undo. I'm just going to pull down 5. All right. So this is what's going to be on our x-axis. And let's find out what the force is going to be. So this is the electrical force acting on the spheres. And this is going to be newtons. So this is calculated using the, and I need to put this in, the spring constant. So I'm going to just say spring constant here. Spring constant of the wire and the torsion balance. Our spring constant will be newtons divided by degrees. So this is equal to, and we found it on our spring constant page. So if I go back, it's spring constant. I am going to select this 1.44048. Of course, I can change it, but we have our electric force is equal to the twist angle average wire twist angle, okay, times our force constant, okay. Now, of course, I can do the same thing that I did before. You guys are going to see that I'm not getting appropriate numbers. So what I want to do, I want to select on Q, hit F4. Again, you guys who are on the Macintosh, find your function key. It should be on the right-hand side above your number pad or somewhere over there. And then hit function key F4. Ooh, looks like function key F4 has, put the superscript immediately there. All right, so I'm going to hit enter. And then I'm just going to drag this down. Okay. So I'm going to make all of these scientific. Okay. You guys can sort out the significant figures. I'm not going to worry about those right now. So we have our charge, which is on the x-axis, and we have our electrical force, which is on the y-axis. Now let's use the Linus function to find out what the slope of the line is going to be. So our Linus function, known y's, that's our electrical force, comma, known x's, that's charge squared, comma. I am just going to say false for now for the y-intercept to be set to 0. And then I'm going to say false for all of those extra values, even though we'll need them. You know what? I am going to do true and true. I did say I was going to do false, but true, true. All right. So we know that this value is the slope, right? So we have 1.35, and we're actually coming out with our prediction. It's here. I'll just go ahead and highlight that. Prediction is 1.40, and what we're measuring is 1.35. So this is the slope coefficient. Slope coefficient, all right, of force to charge squared. Okay. Really don't like it that far over, but so let's look at this prediction. If it's false, let's see what, before I even do that, let's do this. And this is going to be the error. All right, slope coefficient. Am I spelling that right? All right, so now you have your uncertainty here in this measure. Okay. So let's see. Let's do a percent error to see how they relate. Percent error between prediction and what do you call it? And measurement. Okay, this is a dimensionless number. All right. So this is just going to be equal to our measurement. You know what? I'll put some parentheses here. I'll take our measurement minus what we are expecting here. Not intended on coloring divided by what we're expecting. I intended on coloring. So let me make that yellow. And let's change this to percentage. So this is coming out to be 3.89%. It's phenomenal. Okay. If I were to change this to false, what would it be? It increases it, you see? So I am going to use all of my values. So I could say true. Okay. And now, in other words, this is going to give me the best results if I make these choices. If this is my calculator and I make these choices, this will give me the best results or the best predictability. Okay. I do want to look at it in terms of the coefficient being different. And when I say coefficient, I'm talking about the spring coefficient. What if we change the spring coefficient and we just said that this is true? So we know if it's true, it's going to be 1.3785. So if I go over here and I look at the percent error actually goes up. Now, what if I make this one false? The percent error goes back down. Okay. So like which one is which? I'm going to choose the one that has the lowest percent error. But any two ways, here we have a prediction 1.4, and then we have what our prediction. So we're less than 10% on all of these. All right. And just based on where we choose our y-intercept to be, we can reduce it. Okay. I wonder if I did false on this one. Did I do false on the other one? If I did false on this one, this will be the last thing. So that's 1.4. So again, it does go back, and I say, I had true here, 3 point, a negative. So this is under. If we go the other way, it goes over. I mean, it's just like, wow, if we reverse these. And so I'm just going to go ahead and say save so that I won't lose this. And I'm going to end this video. In the next video, we'll look at voltage for 30 points.